So one of the trivial questions is, for example, I have a shift change and I would like to have a summary of what happened in the last shift. Normally, to develop a dashboard like this or a summary like this, you have to hard code a lot of stuff. So you have to describe, okay, like which data is interesting, like overall equipment efficiency or some scrap ratio or something else, how I get it, how I parse it. And then you go to another line. Instead of redoing your dashboard, you can just adapt your prompt. And even somebody in a shift can say, okay, I have another expectations or I have another question. So now LLM can access both. It tries to understand our human logic with knowledge graphs, and then it goes to this bucket. And now it can much better sort and get only the data which I really need. And combined together, we actually, I would say, solve both problems. We can very easily and scalable share like our human logic of
Yeah.
how the data is structured and how to access it.
Welcome to the Industry 4.0 TV podcast. I'm your host, Kudzai Teresa, and today we will discuss generative AI for engineering and manufacturing. And to help me unpack this, I'm joined by Vlad Larshev, who is the generative AI lead at Accenture Industry X. Vlad, welcome to the show. It's such a great honor to have you here.
Thank you for inviting me.
Awesome stuff. So maybe before we kick things off here, could you kind of like just give us a brief introduction, who you are, your role at Accenture?
My name is Vlad Larshev. Yeah, for my background, I'm an engineer, but very early I started, or I discovered for myself software development. It was kind of a magic for me that you can really like implement all your ideas into the real life if you can code. And as my first chief my job said, like developers can everything. It can be like slow or very expensive, but actually everything is possible. And it was really inspiring. And yeah, I tried different topics and areas. So worked as a full stack software developer, combining topics of engineering and software development. And then one of the interesting position I had was the opportunity to build up a software department in a company which was specialized on machine translations. And to be honest, so for me, it was just a software development topic. Yeah. So the question was, okay, how we create our DevOps topics, how we can help to create more adapted solutions for our B2B clients. But through this development, I learned the topic of AI and natural language processing. And the funny part about that exactly at that time, the so-called transformers really began to show their strengths, I would say. So they moved from the papers to the first frameworks and libraries, which you can use. And as we know today, so transformers is exactly the T later in GPT. So pre-trained transformers. At that time, to be honest, the models were much smaller, so nobody was aware that you can do this amazing stuff with this technology. We actually use it only for translation tasks. And today we would say that what we did in the company was B2B fine-tuning of the models for our clients. But the kind of a beauty things about that at that moment, as I said, the models were so small that you really could see how the whole process works. And we have this whole end-to-end chain. So nobody today, I think, would really think that we will train from scratch a transformer with own data collected by hand, basically. So you could buy some, but of course not at that scale we have today. But we actually were really training them by ourselves. The whole pipeline was by ourselves, and this kind of elegance of translation of things like emotions or humor or such a complex topics and concepts which we have encoded in our language in the numbers. This was really exciting. So because translations have to be very accurate, if you especially translate like creative things, like for example, a letter of the CEO to the company on a on a annual report, for example, for the stakeholders or for the market, it should be very precise and understand a lot of nuances. And this was a very exciting time. Later, I moved more like back again to the engineering area. So I joined Umlaut. Umlaut was a engineering consulting company in Germany, which grew very quickly. So at the peak, we had, I think, around about 6,000 people across all industries, from engineering to manufacturing, from aerospace to manufacturing and industrial applications, where my goal was to help to build up our AI and software portfolio in Germany, which was also a very exciting time, where I discovered for me also the complexity, I would say, of industrial processes and the complexity and yeah, I would say like variety in a good term of data in the manufacturing space and how it's organized or not organized at many, I would say, areas and industries. And later, like around 2 years ago, there was an announcement that Umlaut was acquired by Accenture. So now we're officially part of Accenture. And was also a very exciting development for me because now we started to work also with larger clients and we had definitely more capabilities with having over 700,000 people in one company with very diverse backgrounds and skill sets. And as you already mentioned, for the last 1.5 years, my focus area is to driving the topics of AI and GenAI in our industrial applications, with a focus on our DACH region, but in a like our global company, we're working all together, so you get great insights in what's happening across the world.
Awesome stuff. Thank you so much for that insightful background. And I mean, it's clear that you kind of like have been in the weeds, as you explained, kind of like really building models with transformers early on. And we've seen this trend grow like from something that was relatively unknown outside of the AI circles into like the wider market with obviously the advent of things like ChatGPT and things like that. And from that, this generative AI is kind of like being perceived in some circles as a bubble because it can only, generate videos, text, and things like that. And there may be some manufacturers that might still be on the fence really about investing in generative AI, mainly because of kind of like they kind of like not they're not yet clear to them how exactly they could benefit from generative AI, and is it a real benefit? Is it a real promise to transform how they operate their businesses? So maybe can you just kind of like explain to us the business value that generative AI can bring to manufacturing operations?
Oh, absolutely. It's a great question and also very, like your formulation, I absolutely agree with it because looking at this topic from outside, the first of it is, of course, I would be also a bit skeptical about this amount of attention to a new technology. And we've seen several developments like this over the last few years before, where many people say, okay, let's just wait a few years and see what is exactly my ROI and what is the outputs and what is the outcomes of this technology. Also, I think one of the, I would say, challenges in this area, I would say, is almost the word itself. So we call it generative AI, and many client discussions or just discussion of my colleagues, people who are, for example, in engineering or manufacturing, they say, okay, I understand the use case in marketing or maybe in a call center where I would like to process some unstructured data and generate a response or generate an image or generate a marketing campaign. But I don't want to generate anything on my production line. I don't want to generate images or songs about my PLCs. I would like to automate maybe tasks which were hard to automate before. Maybe there's any other advantages. I can access my data easier. Can improve my knowledge management. And this is exactly the right discussion, I think. The point is, which I share, or maybe opinion which I share, is that actually, in my opinion, we are not on the end of this pipeline because the current focus on generating content is just one of the perspectives. In my opinion, the more powerful component of LLMs is the reasoning capability. So for our viewers or listeners who are not aware or maybe not heard a lot about that, you can try at home today in the evening to write some complex tasks to ChatGPT, for example, and try to confuse it and try to write something which is definitely not to be found in the internet. Like try to write, I don't know, I have a table, on this table is an egg. I will put, I don't know, a book on this egg, and then I will like break a leg of a table so it will be shifted to the side. Explain me what will happen. So I'm pretty sure there's not a single line in the sentence which already was in the internet. So you created a very strange situation. And of course, some people say, okay, large language models are only predicted or predicting the next token. That's true. So actually, each time they just try to understand, okay, what is the highest probability for the next token, and they offer you the top one of this list each time. But the point is to be able to predict this token in a setup like this one, or to predict a next token in a recipe for a medicine or drug, or for example, to predict a next token in a very complex legal document is not trivial. You cannot just say, okay, you train it on the end and you just a statistical parrot, as people call it over last months, I would say, or year. You have to understand kind of how things are connected to each other and understand the larger topic or larger picture.
Yes.
And we call it reasoning. So the ability of having a logical understanding, maybe a simple one, simplified, of course. So it doesn't have a whole word picture as we have. Also, because it's learned only on text or some images, so we had more advantages. We could learn about the world by touching things, by moving ourselves, by interacting with this world. So LLMs had a very, very limited, I would say, overview over the materials and our world at that moment. We can speak about the future in this area. But already with this amount of data and training, LLM were capable of understanding pretty many connections in our world and dependencies. And they perform already very well in many areas. Of course, especially in the areas where we had a lot of open data available. At the same time, we see the disadvantage because especially in manufacturing, for example, or industrial environment, many types of syntax, for example, or programming languages are not so openly available. So they're not so well documented. Uh, Models like GPT could not learn about that enough. So they start to think of the stuff to give you some response, which we call hallucination. And this is, of course, additional challenge for application in manufacturing, for example. But speaking about the value of these models, I would mention at least three topics. So the first one is everything what you can summarize as knowledge management. You can imagine on like each plant in each company, we have so many sources and so many ways to store our knowledge, and it's so hard to access. And also, like it's no matter what you start, a Jira, a Wiki internal, some kind of documentation. Like over years, this information will grow. The structure will be so complex that especially junior people who will join, like it takes years to understand where is what, how to access it, and also like best practices of a company are shared across so many sources. And especially for people who are joining a company or have a transfer, this is knowledge is very hard to access. And this, for example, is one of the application areas where we use LLMs as a kind of a universal interpreter, I would say. So LLMs are capable of processing unstructured data in different sources, and you can pretty easily connect it to already now most of the enterprise solutions as well. Having one, I would say, point of entrance for your people to access this enterprise data. And also we, for example, use it already for our 700,000 people across the world. So we are also one of the largest, I would say, users as well for LLMs already. And it's running in our company for already over a year. And I would say it shows that you can scale GenAI
Yes.
pretty well. And the second area is, of course, I would say, okay, content generation, I agree. But as a content, you can understand also topics like, for example, dashboards. So in behind, LLMs are capable not only understand languages like English or Italian, like programming languages is also just a language for LLM, and it understands languages like Python or Java, JavaScript. So pretty early, already last year, we could see that LLM can actually code pretty well because it understands the language and connections in the language in a programming language as good as in a normal language which we use. So we use LLMs to, for example, develop or program dashboards on fly. And the people who watching to our podcast maybe know already Claude, for example, as one of a very nice implementation of this functionality. There's a new functionality at Cloud which you can just access openly through internet. You have to just activate a button to activate artifacts. And you will see on the left side a chat where you can just say, hey, please develop me a dynamic dashboard based on this document. And on the right side, you will get a dynamic dashboard with widgets, with all kind of functions, which will be just developed on fly, even with a framework you choose. You can just copy paste it, for example, to your front end. You can specify, I would like to use it as a plain JavaScript, or I would like to use some frameworks for CSS, whatever. The
Yeah.
nice thing is that you can iterate with that, and you can give you feedback and this context length. So kind of a short memory of a system is so large that you can really develop or iterate over your application in one context and say, please change the colors or please add additional information. Iterating and just chatting with the system, and you will see the results, parsed results, which are already working, like on a server application, on fly on the right side. And I think this is a very tangible way to understand this capability of translating human requirements to code. And maybe just as a closing remark, a third application which I'm very excited about is a point which I already mentioned, uh, requirements.
Yeah.
So I would say most impactful area in my opinion, is this whole process of product development in the industry. So if we look at this chain, starting with requirements, this chain is so complex and there's so many steps, starting from the idea of a product, later to validate this idea, defining the requirements to this product, break them down to sub-requirements, validating them, changing them, understanding how these requirements connected to each other. What will happen if I will change one requirement, which follows with changes to another one? And following this process, we can talk about the area of engineering later, more in a deep dive. But this whole chain from understanding the variety of text-based requirements to the end, to the product which will in the end manufacture on the plant, is a discipline which connects so many different experts together. And this is another very powerful area where we see LLMs as kind of a universal translation engines. So it translates different expectations, different input data, and help us to streamline and kind of a break of silos between different disciplines, accelerating R&D and product development.
So, I mean, kind of like just bringing it into the manufacturing, into the applications of generative AI in manufacturing. So, I mean, a lot of things that manufacturers look to do really is kind of like become innovative about their sort of like, I mean, as you mentioned, product development and also kind of like production manufacturing process, right? How can manufacturers best leverage the power of LLMs to be able to automate and augment these operations?
Sure, maybe we can just to use a framework to have a structure in the description. We can just go along the pyramid and start on the shop floor, for example, and go like upper higher. So this whole concept, for example, of talking to the production data or to the manufacturing, we call it kind of as umbrella name, talk to the factory. And there are many applications of this. So we have on one side like data, okay, how to get this data, how to technically streamline it, how to access the data on OT, IT layers. Is there any efficient way of combining it, which is a complex question itself. And on the other side, there's these use cases. Okay, how I can apply it, what will be benefits? And we can just go maybe through like bottom to the top and
Yes.
see some examples. So one of the examples, for example, if we start on a shop floor, is the area of PLC development. And we have many teams working in this area. Again, it's just coding examples. Um, it's a pretty basis, a starting point we had already 1 year ago. And we started to discover and speak about, okay, how we can automate the process. And especially if you have to make a large changes to the code, so you not go manually through all codes. But later, there are many companies which said, hey, if I already can connect to PLC data, or maybe I can connect already to the low level code of machine, is it possible also like to have a concept of talk to the machine instead of talk to the data? So, for example, if I have a machine which I sell as a service, which is a large trend in the industry at the moment, to my manufacturing line, I would like to save still my efforts in support. Is it possible, for example, to embed into the machine data from the manuals or ticketing systems, and also to access on a bus level the data from machines? So the machine, for example, will give you a reasonable response about the error message instead of like F22 for A, and somebody who is working on a shop floor or in the maintenance understands, okay, the error message is actually, for example, try to change the filter. This kind of data is actually already there, it's just not connected. So we have people who develop, for example, PLCs, or people who are producing the machines for manufacturing on a really bottom layer, where they say, okay, LLM can help, for example, me to access the data, to translate it to a language that's human understand. We can also, for example, use LLMs to develop code not only for the lowest level, but also, for example, for interfaces and displays. There's many examples where clients say, okay, if I have, for example, a new product line and I have to go through each display and adjust a color, for example, or even move some buttons, like it's so much, it's such a huge amount of manual work which I have to be able to do so. And also there in product development or coding, it's just trivial because we already use Copilot to understand, okay, we can use it also in different levels of programming. But then if you go, for example, to the manufacturing line, uh, it's a pretty challenging topic because we have different data sources. So we have ERP systems, we have MES systems, and even before, it was not a trivial to say, okay, I'll make some dashboards. We have all the time you have to have some plugins and connectors to access this data. You have parse this data, and also there. So we have not only we, so we as Accenture are not primary software developers itself. We're helping companies to integrate software for our partners, like, for example, Microsoft and Siemens and Rockwell and all others. So we help companies to scale these solutions and to get best practices in the implementation. So our job as a company is to find a solution, how to combine and I would say kind of orchestrate these solutions in a one scalable solution and scale it, for example, to all plants. And there we have, for example, now super interesting development where we see that there are across the whole pyramid, there's different co-pilots, but we help, for example, our clients to combine with co-pilots to one solution, which, for example, helps, as one of example, to create a dynamic dashboard for shift changes. So one of the trivial questions is, for example, I have a shift change, and I would like to have a summary of what happened in the last shift. Normally, to develop a dashboard like this or a summary like this, you have to hard code a lot of stuff. So you have to describe, okay, like which data is interesting, like overall equipment efficiency or some scrap ratio or something else, how I get it, how I parse it. And then you go to another line and another line says, okay, I need another KPIs, I need another data, my name is not the same, and so on and so on. And now instead of changing all the plugins and going to the code, we can actually give interface where you can adapt your system prompt and say, okay, no problem. If data is already available, if we have already connectors, so of course, there's no magic that data will be not like with LLMs already there if it's not connected. So the whole work before is still there. But now we are much easier, for example, or more lean and more agile in, for example, changes, because now we can say, okay, instead of redoing your dashboard, you can just adapt your prompt. And even somebody in a shift can say, okay, I have another expectations, or I have another question, or even a question in another language. So it was a surprise for ourselves. We had a demo for one client in Germany, and we had the whole demo built in English. Excuse me. And during the demonstration, so it was also this talk to the factory concept where we said you can just ask a question about your production data and get, for example, some statistics and dashboards about your production on fly. And we also added a voice interface, so client could just ask questions. And he started to ask questions in German, and we were surprised because we were not thinking about that it will be the demo will be in German, but it worked without us doing anything, just because large language models also understand several languages. And then a colleague of him, whose plant was a pilot plant, is from Poland, and he said, okay, would it be possible, for example, to have also versions where people can just ask questions in Polish? And we didn't try that. We just said, yeah, just try, I don't know. And actually, it worked directly also in the Polish. So we could actually ask questions. Some of the terms, for example, are also specifically in different languages. And also this worked automatically because LLMs understand like what is the term in which language. So also there, we're saving a lot of efforts. I would say this is like two or three examples,
Yeah.
but actually you can go through the whole value chain, like from understanding like which parts are available from the supply chain to understand, okay, like how to connect my warehouse data better, for example, with parts which I have in Excel files as example. So
Mm.
the variety of use cases is very large. What is, I would say, a challenge or missing part is that many efforts of very talented people in this area in the first step went to classical software development lifecycle topics. So there's many great people working on co-pilots for software development, for MLOps, how to optimize processes for scientists, for example, or for people who are data analysts. What is missing, I would say, are people who are on a cross discipline, who understand, for example, how SAP works or how warehouse management works, and they can combine it with understanding of AI and GenAI to understand, okay, what is the like best usage of this technology? What are the current limitations? What I see a lot that people in manufacturing just open ChatGPT and says here's my bill of materials, like, and then they ask questions which you would not even ask a human, and they also like maybe don't understand like how data comes to it, what is the context of one session, and then they get a bit of frustrated and say, okay, it's like a more like a toy. I cannot use it. Um, and this is, I think, a learning journey for all of us to understand, okay, how to solve like simple problems with LLMs, but especially in manufacturing space where we have so many different IT solutions, we have so many different data formats. As I already mentioned, like LLMs do not know appropriate formats.
Yes.
So we have to use special techniques to teach it or to enrich the data with this data set. This kind of knowledge, I think, is currently like transferring from classical code generation to our manufacturing domain.
Yeah. Yeah, I mean that's an interesting topic also kind of like that's the kind of what wanted to touch on there because I mean in my so I've worked in the manufacturing environment before, and no matter how sophisticated a piece of technology is, if if it's not trustworthy, that they're not gonna use it, right? So if
Yeah.
the data is not trustworthy, they're not gonna use it. And the reason why I bring that up is because, as you mentioned, ChatGPT out of the box or all of these LLMs out of the box, they do not have that domain expect they do not have like deterministic output. It's all probabilistic, right? And it's really hard to rely on it. So those are kind of like one of the challenges that are being experienced by manufacturers. So what I want you to do here for us is kind of like to speak to how these problems are being solved, right? To be able to enable industrial grade generative platform that can be trusted and used in a real production environment.
This is a super exciting question. The first point I would say that humans are also not deterministic, and
Yeah.
we trust humans, but there
Yes.
is a list of criteria, I would say, or our expectation on a human to be trusted. Like for example, we have to understand, okay, like what was the the chain of thoughts, I would say. So how somebody came to this conclusion. If I would say, hey, we have to stop the line, your question would say, why? And if I can explain you what is the reasons, like what is my sources, what is my previous experience, you would say, okay, it's reasonable. If I would say, no, you have to trust it, I'm kind of a black box, nobody will use its solution.
Yep.
And we have the same criteria for classical software solutions, but also for classical AI solutions. There's like criteria, like it should be trustworthy, it should be explainable, it should be reliable, and there are classical for AI topics. But now with GenAI, exactly as you mentioned, it gives another level of complexity because I think it's even tricky because sometimes it sounds very reasonable and very trustworthy, even if it's not, just because LLMs are very good at pretending to understand what we say. And it's a great question. So there's a whole discipline, or even three disciplines, on how to create this solution. So the first one is exactly, for example, how to make it trustworthy and explainable. There's many early development, I would say, in this area. So I cannot say that there is one particular framework which solves this problem. There's different solutions to it or approaches. It's an early research stage by OpenAI, but also by other companies to make it explainable. But there's frameworks which can definitely help. So the first step always, and we learned already is very, very early last year, was of course RAG architecture. Like retrieval augmented architecture is a way, or generation is a way to combine LLMs with data sources. You can imagine if you use your LLM in your manufacturing data, you put a lot of data into one context. So context, you can imagine, is kind of a short memory in our brain. And it's of course very limited. If you try to remember many new terms, which are also sounding similar, pretty quickly you will also start to hallucinate. So is it like ISO 95? Is it ISA 95? Is it ISA 90? Or what is your like breach or to notice it? It's absolutely the same with LLMs. They try to remember things by having how we call it like multidimensional space, where we try to place all this data in a vector space. And if this data is very close to each other, it's very easy to confuse it, exactly as with humans. So we have also as a human have to write things somewhere down and to be able to access it later. Exactly the same analogy we have with LLMs and GenAI. So GenAI are good at simple things or to have a simple reasoning. But if you have a complex task, it will try to answer it, similar like a child in a school, which you brings to front of a class and say, please explain me what is the most important advancement of, I don't know, Napoleon. If you never heard about Napoleon, it will try to answer something. But if you understand the history, pretty soon it will say the child is hallucinating
Yep.
in the modern term. The same with AI. So most of them have a system prompt that you should be helpful assistant, and it tries to obey this system prompt. And it tries to be helpful, even if it doesn't know how to help. And how we can solve it, or how we solve it, is that we give it additional memory in a special database. This is one of the solutions, which kind of a mimic also how our brain works. So, for example, if you in our brain will say like color red, there are certain areas in your brain which will be activated, and red could be a fruit, red could be, for example, I don't know, some period of history for you or your car which you would like to have. Pretty similar concept we have with this vector databases, which try to arrange all the data in this space of multidimensional space. So LLM can just easily say, okay, like you ask something about, for example, programming, or you was interested, for example, in a particular part of this machine. I will just try to get to the my vector database, make a request, and just grab with like wall bench everything which is close to this term. That was the first step forward last year for the whole industry for us. So we discovered this rack architecture, and in the first glance, all of us thought, okay, problem solved. And
Yep.
now it's state of the art. So each application, I would say 90% of them have a rack database behind. But also there, we faced with similar challenges like our brain has. If you try to arrange all the data in this clouds, I would say, you always have some kind of data that's so close to each other that it's hard to distinguish. Like, what is the difference between different terms? Uh, as I described, if you have a new term and you have to understand, okay, what is the similarities? You can imagine, for example, you have a train and you develop application for a field engineer who should make a maintenance. It's one of the very common use cases at the moment for large language models to be our support for field engineers, for example, who go now on plants or in a maintenance. And instead of having like 20 manuals, they would like to have now one tablet or some data they can input and get all relevant links to the documents and manuals from one interface. The challenge is with this approach that if you say, okay, I have a problem with oil, for example, like there's 100 different places in a train where we have this problem with oil. And if you will perform this question to your vector database, you will get just so many chunks, which again will just fill up your context, and it will be not a feasible advancement. So last year again, many people said, okay, like LLMs and RAG is also just a toy. We have to wait a few years. And also there, like the community around LLMs is so large and so active. And this is one thing which I'm really excited about, that I would say for the first time, we have such a high concentration of people in one technology like AI, and that we have daily advantages and new solutions to these problems. Just because AI, I would say, is so democratized now as it was never before. So
Yes.
before, AI was kind of a like I was isolated discipline. Yeah, you had to have your data, you would train it with your Python frameworks on your laptop. If it doesn't work, nobody understands actually why, and it was very hard to access. And now with ChatGPT, like everyone can use it, and it's accelerate also the investment from the companies, which is huge over the last time, brings a lot of very talented people in this area. So what we figured out how to improve the accuracy, especially in engineering and manufacturing, with LLMs is, for example, of using knowledge graphs. So we have now a combination, which kind of a best practice at the moment is having one kind of a bucket memory. So rack is kind of a bucket. You just threw everything into this bucket, and you hope that LLM will get the right piece of the bucket by your request. It depends a lot of how you organize your data and how you organize this bucket. You can get better or worse quality, but this bucket is not sorted. So you cannot just say, hey, please, like I have two different plants, and this plant, for example, is specialized in this product, and another plant is specialized in another product. It's not possible. This bucket will be randomly sorted. So this kind of understanding, so what is, for example, my parts? How these parts, for example, is organized? Which materials do I have? For example, what is the availability of these materials? Or in which warehouse, for example, I can access these materials when, and what are, for example, the processes behind that? This kind of information was very hard to teach, I would say, to our LLMs. What knowledge graphs allows us to do is to add this additional ontology, so our human understanding to this data, and explain how these data points are connected. So now LLM can access both. It tries to understand our human logic with knowledge graphs, and then it goes to this bucket, and now it can much better sort and get only the data which I really need. And combined together, we actually, I would say, solve both problems. We can very easily and scalable share like our human logic of
Yeah.
how the data is structured and how to access it. And also we can easily, I would say, chunk a large amount of data and put it in a memory which is very scalable and add sources to it. So this is another very important point of this explainability, that if I now have this command of stop the line, or for example, like last year there was an accident, I don't have to rely on this data anymore, on or this message anymore, because now my LLM can provide me a short link to the source
Yes.
or piece of the content where I say, look, this is exactly the link, or to the report or the accidents report, or for example, to some order from the last year. And I can directly jump to this file. And this file could be in my MS system, it could be in SAP, it could be in Salesforce. This is no matter. But I can directly see the source, which of course highly improve trustworthy of the solutions.
Awesome stuff. Awesome. So, I mean, I want us to kind of like go into the actual use cases of generative AI, kind of like go explore a few of those to give our audience a clearer picture of exactly where this generative AI could be applicable. Are we currently at the stage where it is now robust enough for a lot of use cases in industry and manufacturing?
So we have very different use cases, and I think there's hard to give you one answer to this question.
Yeah.
I would say it depends on the use case, and it depends also how you measure the robustness. So in some of the use cases, we say, okay, like we have extremely high expectation on the accuracy. For example, for visual models, yeah, if we say go in the direction of quality assurance,
Yeah.
like the first experiments, which we run like last year, some of them had an accuracy of, I don't know, 92%, for example, where human would say, okay, my accuracy is maybe in a similar level, is good enough, but you cannot use it in industrial application if you have like 10,000 parts in a week and
Yeah.
you will have like 8% of the wrong answers. It's not usable at all. But there's also other areas of application where we have, for example, more like suggestion or generation or summaries, where we have, for example, human in a loop, and there is no expectation a higher level of accuracy. And then these areas are already very highly uh, interesting, I would say, for usage of LLMs. So exactly as you mentioned, if your expected output is not deterministic, like the part is right, the part is wrong, or I can start, I can stop, or you're not triggering like next steps, then you can definitely use and benefit from large language models already today. These further steps, like for example, using LLMs as kind of an actor, as triggering, for example, further processes, so as an active part in your chain. I would say we are not there yet in many areas. So we still at the stage of not autonomous AI, but rather human in a loop, where AI just enrich or enhance the work of a expert or somebody on a field. Um, in these areas, AI can just improve the efficiency or access the data or simplify, for example, the process or automate it in areas with not have this extremely high expectation and accuracy. So in these fields, I would agree. I would distinguish between these fields and have, as a company, a matrix where I have estimation of my expected output from the use case,
Yes.
my expected expectation, for example, on topics like accuracy or urgency, and also what is the return of investment. So of course, like investing millions in a use case, which has saved me like less as I have with current setup doesn't make sense.
Yeah.
So there are, as we call them, no regret topics
Yes.
where we already see the usage of it. Um, and I would definitely prioritize them.
Yeah. And is there a case to make whereby you're saying, even though currently you may not cover every aspect of your, of the use cases that you want to cover with LLMs, however, it wouldn't be wise to wait until they are fully formed because there are companies that are using them right now to really gain that competitive advantage, and they're building a foundation. They're building the literacy of working with them, such that when you get to that stage um, when they're fully capable, you're kind of like really able to then make 100% use of them. What do you see out there?
Yeah. Also here, I would separate it in two areas. So I would definitely suggest not to follow this fear of missing out. That you will say, okay, if I not use GenAI, like I will be too late, and my competitors will be much faster and further. Because on the one side, exactly like with all technologies, what we've seen in the past, that there's all like early adopters and there's companies which are followers, but on some point when technology is really uh, on a high maturity, for the second group uh, to reach out to this level of people who are early adopters is not most of the time as complex as to be this early adopter from the technological part of the question. One example of it Like last years, there were some companies would say, we will train on foundational models. And there was one company in the financial market, Bloomberg, which said, okay, we would like to be like OpenAI over finance. And they invested billions, so 1 billion,
Yeah.
and creating their own foundational model for finance industry.
Yes.
Like 8 months later, there was a developer who just took the open source model, but like 6 months later, and he just invested $100 in fine tuning on AWS with data which is also available, and he got the similar or even better benchmarks as this model, which was already like 6 or 8 months older. So this is
Yeah.
amazing, and also very like alarming, I would say, for people who currently make the investments. But we shouldn't look at this question only from the technological part,
Yes.
because it's like to say, okay, I will buy my computers in the beginning, 10 years later, because they will be better. So I will not have my company any PC at all, is definitely the wrong approach. Because it's not only about having the right hardware or software in your company. So if of each of listeners and viewers of your podcast knows that the technology is never the only one solution. So you always have like these three components: people, solutions like software, and processes. And each transformation only works if you really have three of them. And the special thing about GenAI, I would say, is that you will, I would say, not be able also next years to buy out of the shelf a ready GenAI solution for your plant or for your production line, because you have to adapt it, or you have to understand like your own processes. You have to upskill your people. You have to teach your people how to work with the system. It should be adapted to your company. It should bring to you the value. And this process, so to answer the second part of it,
Yes.
in this area, you should invest as soon as possible, because we see the change in the market. We see these large changes in the way how we approach many problems, and there are already many companies which making tremendous amount of I would say advantage through this early adapting. But we also can learn from these use cases, understand, okay, what works, what not, and you will be able to buy this working solution soon, but you will be not able like to with one click enable your people and change like their thinking process and inspire them to adapt and use AI just by, I don't know, an email or having some, I don't know, nice UI. So it's a learning process for your company. It's also like with the previous topics, yeah. So many AI initiatives in last year failed because the data foundation was not available, and it was very large amount of efforts for the company to invest in this company. And on the other side, they said, okay, like benefits are not so clear. But now many companies said, okay, now we understand the outcomes will be large. We have this high available use cases, and we will invest in the better data preparation. They are already working on their internal private solutions where we can privately talk to this data, generate new content. But also this process takes time. And like GPT 5, 6, 7, or 10 will not able to do this homework for you. And this is definitely an area of the largest impact, I would say, for the next year. So instead of running like for the hottest topic on the market, like newest framework or newest solution, I would definitely to suggest invest in your people, like understand the technology, understand the best use cases, invest in this no regret deals, which already works for other industries. So you can look up a lot of from industries like automotive, for example, um, who really early adopted a lot of great use cases, and they already worked there at scale, and see, okay, is it something I can adapt for my industry without high risks? And also invest in this journey of transforming your company, transforming the way how they operate. So it doesn't make sense that each department creates own center of excellence or AI competence center. In many companies and many clients of us, this is also a change in their governance, is change in their processes to understand, okay, how we can learn from different departments together,
Right.
which data we can share, and how where does it make sense to invest, how we prioritize our use cases, how we measure them to understand our output, and how we can prioritize them. This is absolutely not so trivial, especially in LLMs and GenAI use cases where you actually pay per token. and
Yeah.
the models are changing like every 2 months.
Oh, yeah. So speaking about use cases, so maybe let's kind of like jump into some use cases, generative AI use cases in manufacturing. So these could be real world examples with some of the customers that you've worked with, or it could be general use cases that you see out there. So could you kind of like give us a few use cases?
Yeah, sure. So one of the, I would say, use case I currently really like. So we call it virtual mentor for manufacturing, and it helps people, and especially like junior people, to access the distributed knowledge on the shop floor. And as you know, this is a very like urgent problem, especially in Germany, that many people who really understand how the processes work and how to solve some problems are now a very short before their retirement. And this topic of knowledge capturing or knowledge organization is highly relevant. So to give, for example, people on the shop floor a system which is easy to use and which can also help the knowledge to capture this knowledge and also be easily maintainable is a super interesting use case, which we're currently discussing with many of our clients. As you mentioned, like there's 2 points which brings this all the solutions to a fail. The first one is if the solution is not reliable, but we already talked about okay how we make it more reliable. And the second one, like if I have to use a new solution instead of my previous one, so now I have two screens, now there's another interface, now I have one tool more, also like nobody will use it. Like I've seen many concepts also last year where people had great ideas of using ChatGPT or some GenAI tools on the production lines, or for example, also in engineering processes or on the shop floor. But people say it like cannot imagine like going to a display and type something. So many times I have like not clear hands or have gloves some in some areas. Yeah, I cannot start and type the question. This is not reasonable. Then people say, okay, no problem, we'll give you a headset. People say, okay, I have no connectivity. I cannot access like any server.
Yeah.
So this kind of real world adaptation, I would say this is something which makes a difference from a POC to really a solution which being used. And as one of the use cases, this idea of manufacturing mentor, I would say, is one where we see a real good feedback from our clients. Um, Also, as I mentioned just before this, because this knowledge is very distributed. Another area which currently highly demanded is this, for example, shift change dashboard. So I would also say this is a very nice entrance level use case for manufacturing because you can combine different sources of the data without hard coding each plugin. And there's also already many plugins available. So also many of suppliers currently working on their kind of
Yes.
GenAI adapter. So you have easily additional layer over your IT solutions and can say, okay, I have specific questions or I have specific data I would like to track over time. And I would say starting with these two use cases, a very nice entrance level to develop or to discover more use cases later.
Awesome stuff. Yeah, so I mean we're running out of time, but I really want to kind of like get your sense on what you sort of like see as the future of generative AI and where do you see things going and how are you as Accenture sort of like looking at this and positioning yourself to be able to better help your clients or customers? What's your view on what's to come in the next? I mean, things are moving so fast now. It's so even it's not even possible to kind of like project things in 5 years now. So maybe I would
Absolutely.
say in the next few months, going to 2 years, 3 years, what kind of like what do you see as
Yeah. Yeah, I agree. I think it's you can make some projections in the future, but it's so hard because
yeah,
next day will be another announcement which will change the landscape. I think what is already kind of a fact, what we can expect by already investments which companies already did, that the adoption will not slow down. It will. It's already in a process. Also, like many companies invested now a lot in changing their structure and governance structure within the company. So it's not something we can directly measure. And that's why I see also this kind of a skepticism from many people who say, okay, what are the benefits? Where are they? I think in many levels, people oversold this technology and said, okay, like next month you will be able to develop your whole plane with just a one prompt.
Yes.
And somebody, I think in some areas, buy that. Um, what we already see that there are specific challenges and specific like chain parts which was almost not possible to automate before, just because it's very complicated to work with unstructured data, or for example also images, on such a complex environment, like for example in manufacturing. So now when we see on this technology chain, we see, okay, like the frameworks are still like very, very in the beginning. Like for example, LangChain is the most used framework. It's still not in a stable version. So we, for example, would never deploy a solution which is have not like a first stable version
Mm.
available. But as you mentioned, like this technology is moving so fast that we already have to use what is available, and the technology itself is changing so rapidly that also we like have to stay daily at the front of the changes to understand what is the best or the best to be used. And what's for us, for example, or also for industry, I see as a development for next years. I'm pretty sure that if you're in a position to decide which tool to use, you will be really, really confused in very few months, because each of your supplier will say, "Hey, I have a new GenAI solution which will change the way how you work." And most of the clients or most of the partners will have like 10 different companies pitching them their 10 different co-pilots.
Yeah.
Each of them will promise like your efficiency will be 200% higher, your cost will be 500% less, and maybe really this is the benchmarks which you could measure in some specific use case. But as we spoke before, like this is not some out of the box ready solution which you can just ship and deploy to each company's process. You need the integration. You need to understand like how to adapt it to people, to your data which you have in the company. So I think to really, really get this advantage of this technology in your company on your manufacturing, there's two things you have to do. The first one, and I already see that company do that, they will invest a lot in their restructuring and their people to explain how to work with this new solution and to understand, okay, what are our benefits, where we should start, what does it mean for our people. And there is not like AI department anymore or people who do software development. Like with new technology, everyone can access this data and make their experiments. And making people excited about this development, give a people secured environments where people can experiment securely with their data without leaking the data to the internet and having a danger of legal use cases and losing the IP rights, is the first large to do for all companies on the market.
Yeah.
And the second challenge for the next 3 years will be the move from having 10 co-pilots, which nobody can really like capture this value from, to new processes. Because I believe companies do not need like 10 different co-pilots. They need better processes. And if I have, for example, my R&D process, so I develop my products, I don't care if it's like AI or GenAI, if it's
Yeah.
just some automation. I would like to, for example, my products be developed quickly. And I see already that all suppliers are working on providing their co-pilots and their solutions to optimize like their pillar. But I'm absolutely excited about like our role in that. So we as Accenture are responsible to integrate with different solutions or pieces together in a new process. And I think this is something which really like will unfold over the next months and years, where we see first companies which not only integrate the co-pilot, but really reinvent their R&D, for example, and combine classical approaches, deterministic approaches, GenAI approaches, for example, to develop their cars faster or to iterate faster, to have a shorter time to market, to be able, for example, to handle the complexity of these smart connected products and be a more efficient manufacturer, and have the people to work with this complexity or be easier compliant being able to regulate, to understand regulations faster or implement new changes in the products without having a huge shift in a product. And these two things, so changes in the structures and reinventing the processes itself and not just using co-pilots, I think this is already pretty sure will be very exciting development for next years, regardless of new features and new technologies coming to the market.
Interesting. I mean, it's really interesting that throughout this conversation, you've time and time brought the concept of the structure or the people, the workforce, and it's interesting because a lot of manufacturing executives spoke about the lack of skills as
Mm.
kind of like one of the big challenges with the adoption of AI. So it's kind of like really seems to me again from what you're saying, this idea of structure and really bringing people and kind of like into the center of these technologies is going to be a big determining factor as well.
Absolutely. And interesting point about that is our internal study, which we did about ourselves. So as I mentioned, we are like 700,000 people now using our internal search engine, for example, which is now also enhanced by GenAI. And I think this is a very interesting development because we expect the technology to be better. But in the same time, we as a users also learn to adapt our behavior to get better outcomes. And I think this is something which we will see over the next years, that people will see the benefits, real measurable benefits from this technology, and will also learn, for example, to prompt better. I'm not really a huge fan of this word of prompt engineer because I
Mm.
think like prompt engineering is like kind of a writing, or I don't know, it's will be a basic skill, and it's more about how good you are at that. So there are people who say, okay, I'm a writer, but it's still the question, okay, what you write about this discipline you are. And I think also here it will be kind of a native skill for all of us, how good we are at interacting with new colleagues, I would say, AI-driven colleagues. And what we've seen in our queries, so I seen our report on how our queries from our employees changed last year from
Mm.
January to around about end of the year. And the funny part about that, like on the January, maybe I don't know if you remember also like how people before asked questions. So like 2, 3 years ago, if you are, I don't know, system administrator or you're in IT, like everybody said, hey, just ask better questions. Like people hated that people wrote in a ticket like my laptop doesn't work. And you have to ask like 10 different questions there. What is not working? Like, is it not like starting or the fan is too loud? And it was kind of a limitation, I would say, of all of us. We were bad at asking questions. And GenAI taught us actually to be a better question asker. Because now we see, for example,
Mm.
last year in our internal system, people asked like report automotive environment. You think, okay, what are you searching for? What do you
Yeah,
need?
yeah.
And people were really unhappy that our search engine or our knowledge management system in our company was so bad. And now I see the same queries. Now people are really, really awesome at understanding like I searching for a report on changes on the KPIs in the automotive sector
Oh,
for this
wow.
specific industry and so on. And this was a natural development for us as a user. And this is kind of a parallel development. So LLMs and AI better understand our expectations, but we are also getting better and working with them. And I think this development is also not to stop. We do it just naturally.
Oh, that's so fascinating to find out that technology is really influencing also our behaviors to such an extent, right? That's really
Definitely.
fascinating. So, before you go, do you have any last words? Where can people find you? And anything you want to say to the audience?
Oh, definitely. So I'm having like a so I'm really interested about the what are the next steps to bring GenAI to industrial scale. And in my opinion, like we are in a stage of early, so making the bridge to your audience. If we look back, what's happened with IoT as we brought it to industrial IoT, there's kind of a, I would say, list or expectation from the industry, uh, what it needed to industry to trust the solutions, to be able to maintain them. And we did a great journey in this development. But for LLMs, we are really, really at start. So as I think we described together in this podcast, we see great foundation. we see great building blocks. And there will be definitely applications in many industries which already will work. But I'm excited about bringing to industrial level, not only like from the use case level, but also from the approach. And in this area, there's uh, so much to do, and there's so much exciting think work as well. So if you're not started to work on this industrial application of GenAI and you're not discovered any applications, how you can use GenAI in your area, I can only encourage you to experiment in a secure environment without a company data. You can generate also with GenAI synthetic data, which is secure. It will be just a dummy data. But just be curious because there's a nice quote from one of the guy. I think he started um, some incubator. I cannot remember anymore. Uh, the Scott Belsky, and he said, creativity is the new productivity. And I really like this quote because I think really it's very well describes this new approach that we have to learn ask better questions. And there are many people who are working on these questions for software development, for marketing, but to find these right questions for manufacturing or engineering, I think this is like a gold mine of great ideas and brilliant startups and yeah, excellent developments, which we definitely need.
Yeah.
So if you're interested in this kind of topics, I try to bring it together in my newsletter on LinkedIn. It's my personal account. I would be really excited to talk to anyone who is also thinking in this direction. And I think, yeah, we will see a lot of development in this area together as a AI and industrial community over the next months. And I can only be excited about all people joining us.
Awesome stuff. Yeah, we'll certainly provide links to Vlad's LinkedIn account here. I've certainly myself been benefiting from the insightful posts that
Thank
he's
you.
been putting out on LinkedIn. So for any of you who want to check it out, you can always just check the link in the description here, and then you can find all of the social accounts for Vlad. So Vlad, thank you again for taking the time to join us today. It was such a fun conversation we had today. Really appreciate it.
Thank you. Thank you for having me. And also a big fan of your podcast, also with the previous episodes. And it was a big honor to be part of it. Thank you.